Screen screen is visible. So this was the question, Chandana, right? Okay, everybody solve this question. ये क्वेश्चन सोल्व करना है अभी कि एक कप ऑफ टी cool from 90 degree to 80 degree Celsius in tea time. Okay, so example T1 temperature is 90 degree Celsius, T2 temperature is 80 degree Celsius, time taken is T. When the room temperature is 20 degree Celsius, time taken by similar cup of tea. Similar cup of tea means constant value will be same. That is the meaning of similar. Example, if we have similar wire, then you know the resistivity will be same, right? So if you have similar material, constant will remain same. In second situation, T1 dash is 80 degrees Celsius, T2 dash is 60 degrees Celsius, and T naught dash is again 20 degrees Celsius. What you have to calculate is time taken by the similar cup T dash in the form of T naught T. This is Newton's law of cooling. Topic name is Newton's law of cooling. Solve it and then tell me answer. Newton's law of cooling. Let me show you options also. Is this visible for everyone? Huh.
सर
Barinder, what is the
ऑप्शन
formula for Newton's law of cooling?
सर ऑप्शन बी होगा क्या? ऑप्शन बी.
Option B. Check it once again. एक बार और check करो. What is the formula of Newton's law of cooling?
Sir, dq by dt is equals to k body temperature minus surrounding temperature.
This is minus.
Surrounding temperature.
Is this the formula? Right. And here dq is not heat.
No, sir.
B. Here Q is not heat. It is the temperature that is reducing. Okay. So what is the temperature? Change in temperature in first situation. 90 degree. Final minus initial. What is the final value? 90 minus 80. Time taken is T. K value, you can take minus to the other side. K. T1 90 plus 80 divided by 2 minus 20. Yes or no? Here you will calculate K value. Got it? Here you will calculate K value. Same K value you will apply in the second reaction, same formula. dq value change in temperature is 80 minus 60 divided by time T dash is equal to minus K. Temperature is 80 plus 60 divided by 2 minus 20. Chandana asked me doubt. Do you have doubt from this equation 1 and equation 2?
No, sir, no doubt.
So this is the formula, and this dq is not heat, it is the change in the temperature. Okay, it is a change in temperature, not heat. So you will put the values T1, T2, T0. Easiest way to do this, take ratio of them. You don't need to calculate K value. Okay. What people will do, they will first calculate K value and then they will put K value in the second section. No need, just take their ratio. K value will be cancelled out and now it will be easy. Isn't it, Arpit? अगर रेशियो ले लेंगे तो इजी नहीं लगेगा, कैलकुलेट ही नहीं करना.
मैं दूसरे मेथड से क्या मतलब जो आप
पहले
बोल
के
रहे हैं?
पहले
हाँ
के को कैलकुलेट किया फिर उसको सेकंड रिएक्शन में डाला.
हाँ हाँ
वो सही मेथड है बट लेंथी मेथड है. ओके.
हाँ
If you are calculating K value in the first instance and then using it in the second equation is correct, absolutely right method. But remember in exam it will take more time. Example here. Here if I am taking what is the above value? Above value 10 by T is equal to minus K. 90 plus 80, 170, 170 by 2. 85 minus 20. 65 divided by 20 by T dash is equal to minus K. 80, 60, 140 divided by 270 minus 250. K cancel. Now it will be easy. 10 by T, 20 by T dash is equal to 65 by 50. Now tell me 2, 25. So T dash will be equal to 65 by 25, isn't it? Yes or no? T. बताओ. Which one look easy? Arpit. K value put करके निकालोगे या ऐसे निकालोगे?
नहीं ऐसे रेशियो निकाल.
See, both method are correct. I'm not saying ki you can't do this method. Even they are doing. But remember, in NEET exam, we don't have time. Time is the main constraint. You know answer, but if it is taking 2 minutes, question is of no use. अगर 2 मिनट लग गए तो कोई यूज ही नहीं है उस क्वेश्चन, वेस्ट है टाइम. ठीक है. Done.
नहीं मैंने रेट ऑफ कूलिंग को इंटीग्रेट करके किया.
इंटीग्रेट.
हाँ लॉन्ग ना कर,
अच्छा,
लॉन्ग ना कर.
इंटीग्रेट करने का तो फिर जरूरत ही नहीं है ना. लाइक यू आर नॉट सपोज टू डू इंटीग्रेशन. कैसे करोगे? dt का इंटीग्रेशन, dt की वैल्यू खुद ही दी हुई है t.
हाँ टी इज इक्वल टू 1/k लॉन T1 माइनस टी सराउंडिंग डिवाइडेड बाय T2 माइनस टी सराउंडिंग.
हाँ
उसके बाद टी का वैल्यू आ जाएगा, के का वैल्यू आ जाएगा. दूसरे केस में भी
हाँ
ऐसे करके सब्स्टिट्यूट करके निकालना. ऐसे भी आ सकता है.
हाँ. बट लेंथ थोड़ा सा डिपेंड करता है कि तुम्हें कौन सा है. इट ऑल डिपेंड कि तुम कंफर्टेबल हो तो तुम वो कर लो. होना चाहिए क्वेश्चन बस. एनीबडी हैव डाउट फ्रॉम क्वेश्चन नंबर 19?
No.
चंदना,
No, sir.
अन्विता,
No, sir.
लरिंदर,
No, sir.
प्रतिज्ञा. तो प्रतिज्ञा, you know in adiabatic process PV gamma is equal to constant, right? So this is adiabatic process. You have to apply the ideal gas equation, correct? And you know we did by 3 different methods. Ki if PV is given, how it is PV is equal to gamma is equal to constant. Then you have to tell me what will be the TV powers, and you have to tell me what will be PT powers. All three will be constant. Calculate. We did in class, but you have to solve it now. And you had 3, 4 PYQ based on this. PV gamma is equal to constant. If you know this, you can derive remaining by using ideal gas equation. PV is equal to nRT? Tell me the answer.
Option D.
Yeah, answer is correct. I'm asking derivation of this. Varinder. Answer एकदम सही है.
प्रेशर तो सर डायरेक्टली प्रोपोर्शनल होता है ना उसके टेम्परेचर के.
डिपेंड करता है, वॉल्यूम कांस्टेंट रहना चाहिए. वॉल्यूम शुड बी कांस्टेंट if pressure is directly proportional to temperature. है ना? It is. ये लो सेक लो. Arpit, got your answer?
नहीं यार.
Solve करो. Use PV is equal to nRT.
वही कर रहा हूँ.
वरिंदर, प्रतिज्ञा एंड अन्विता, we did this in class. मैंने पूरा derive करके भी दिखाया था. And you have to derive now. Because I can show you more than 4 questions. And you can expect even this year. Popular question. See, if PV gamma is equal to constant, then let's take PV is equal to nRT. Okay, nr, these two values are constant. Can you say P will be equal to nRT by V? Correct. So instead of P, can I write nRT by V? Here it is V gamma is equal to constant. nr can go to another side and become constant, new constant. T, V, it will be gamma minus 1. That's all done. Just give me a minute. Hello.
हेलो.
हाँ जी. हेलो. क्लास कर रहा हूँ उनसे. मैं कॉल करता हूँ फिर उसे. मुझे टेक्स्ट कर देना. ठीक. ठीक. देखता हूँ. Everybody understood this? So here
Yes sir.
value will be T will be same. This is gamma minus 1. What is the gamma value here? 2. What will be gamma minus 1 value? 2 minus 1, 1. Now solve PT part. What your answer? PT part. Am I audible, guys?
Yes, sir.
हाँ, निकल गया आंसर अर्पित? Arpit, you got your answer? See, let me
सर मेरा
explain this.
निकल गया
Very good. क्या आंसर आया?
P1 माइनस गामा एंटी गामा
P1 minus gamma T
टी
gamma.
गामा
Okay. Chandana and Arpit, for you, I am deriving this again and I am trying to explain ki what exactly it is because other three people know this. See, normal in isothermal or ideal gas equation, you know PV is equal to nRT. In adiabatic process, PV gamma is equal to constant value. In adiabatic process, this is only for adiabatic process. Remember, we use gamma term only in adiabatic process, nowhere else. But this is the P and V form. If we want to convert into the T and V form, what should be the value? How to calculate? V is same. You have to convert P into T. How to do this? PV is equal to nRT. So P instead of P you can write nRT by V. Number of moles are constant. R is also constant. So you can say P directly proportional to T and inversely proportional to V. So instead of P, you can write instead of P, you can write T by V, and it was already there. So you can imagine T V gamma minus 1 because here it is 1, above it is gamma, gamma minus 1. Any doubt?
No, sir.
No.
Now in same way, you can calculate for the P and T form. How to do this? Example, you know PV is equal to nRT. So you can also write V is equal to nRT by V. Use this form. P remains same. Sorry, here it should
I
be.
think P on P.
So P remains same. V remains same. It is gamma. Instead of V, I am writing T by P. Why? Because volume directly proportional to temperature, inversely proportional to pressure. Right? N and R are constant. Is equal to constant. Here, or I think there was some network issue, guys. Chandana, Arpit, you understood all the three derivation?
हाँ समझ गया।
Yes,
क्या
sir.
क्या इसमें डायरेक्ट बस आइडल गैस इक्वेशन लगाना था अर्पित?
जी जी
आइडल गैस इक्वेशन पीवी इज इक्वल टू एनआरटी ही लगाना था, बस हम डिराइव कर सकते हैं तीनों।
yes
Chandana, we are simply supposed to apply PV is equal to nRT ideal equation and we can get all the three value, right?
Yes, sir.
Now, according to the question, if you understand these three derivation, according to the question, gamma value is given 2. Question number 19. 19 or 16?
16.
Huh. So, now you know these three equation. PV is equal to gamma 1. Second, if you take this TV form, TV gamma minus 1 is equal to constant. And last was, if instead of uh, this will be 1 minus gamma and temperature gamma is equal to C, right? These were three equations. And gamma value according to this question is 2. Gamma value is 2. So can you say PV square is constant and TV 2 minus 1 TV is equal to constant. And third, P minus 1 T 2 is equal to constant, or you can say T square by P is equal to constant. Correct? Now it depends what is given to you. Example in first topic, P and V. Let's see this equation. P and V. See, can you say V square inversely proportional to the pressure? Right? According to this equation, V square inversely proportional to pressure. If volume increase, pressure will decrease. So this is wrong. If V1 is greater than V2, then P2 will be greater than P1, right? Normal equation is also applicable here, right? Any doubt?
No, sir.
Let's see
no
let's see second situation, P and T. This one. This is like T square by P is equal to constant. It means T square directly proportional to P. It means if pressure increase, then temperature will also increase. Both are directly proportional. If T2 is more than T1, then P2 should be greater than P1. This is also wrong. Correct? Because directly proportional. If T2 is more than T1, then P2 should be greater than P1. Third question. V and T equation. V and T equation is Vt is equal to constant. V is inversely proportional to temperature. Okay. V is inversely proportional to temperature. If temperature increase, volume should decrease. It should be V1 greater than V2, right? And last, Vt same situation, and you know both are opposite to each other. Make sense? Now you tell me. If you know these three equations, and more than that, if you simply know one equation, PV gamma is equal to constant, can you solve this part? And can you clearly tell all the four options, right?
Yes, sir.
And I did this in notes. Let me check. I sent you thermodynamic, na? Thermodynamic short summary. Let me open your group. I am searching for your handwritten notes PDF. Organic, thermal property of matter, thermal property of matter, thermal property of matter. Yes. Thermodynamics. Now you tell me. We did this part. CPCV, CPCV.
Super Lego.
See, this is direct from, and I explained you how to derive this. PV gamma is equal to constant. Don't remember all three, only PV gamma. That is more than sufficient. That's why you have to revise these notes multiple times. Sandana, any question? Anybody have doubt from this topic?
No.
No, sir.
And that's why you will see, ki Chandana, even if you see answer, you can't understand how it, like we got all these answer, right?
Yes, sir.
Yeah. So that's all, guys, for this. Now we can shift to our new topic, and new topic is this kinetic theory of gases. I have to start new PDF. Kinetic theory of gases. We go for 2020. Yeah. So kinetic theory of gases. Anvita, how many state of matter do we have?
Three.
Three. Pratigya, how many state of matter do we have?
3, 5.
Three or five? Is it three or five?
दोनों हो सकते हैं
ऐसा कैसे?
मतलब वो था हमारा एक था मतलब एक प्लाज्मा स्टेट वाला और एक आइंस्टाइन का समथिंग कुछ था
Both sides
Correct.
and condensation.
Bose-Einstein condensation. So we have total five state of matter: solid, liquid, gas, plasma, and Bose-Einstein condensation. Where density of the material is very, very low. Best example is cloud. Cloud are not pure solid, not pure liquid, and not pure gas. Right? Out of this state
सर
of
BC
matter, yeah,
सर BC होगा BC मतलब प्लाज्मा के बाद BC
Bose,
BC
uh, Bose-Einstein condensation, BC. Huh. So out of these five state of matter, we have gas in our syllabus, kinetic theory of gas. Barinder, what is the basic property of gas? Just basic. Barinder. Arpit,
Don't have will depend shape and size. Moving in
yes.
random direction. No attraction,
Uh,
repulsion, interaction between two particles, etc.
hmm. So they don't have well-defined volume and they don't have shape and size, right? Shape is changing according to the container. Volume is also changing according to the container, right? Distance between the particle is more compared to solid and liquid. Distance between gas particle is maximum compared to other two. This is the basic property. Now we are moving to the proper kinetic energy of the gas. And when we talk about kinetic energy, you know these particles keep on moving. And if they are moving, they have kinetic energy, correct? And if they have kinetic energy, what is the normal formula of kinetic energy, Pratigya?
half mv square.
Half mv square. This should be the normal formula of the kinetic energy. But one more thing, in gas, particle move randomly. There is no particular direction. You can change the shape and then direction will change. No. Anvit, sorry, Arpit,
Okay.
other than the this random motion, what are the different type of motion you can expect here? कौन कौन से मोशन हो सकते हैं रैंडम डायरेक्शन में जब मोशन होगा तो
Vibrational motion.
वाइब्रेशनल मोशन कब होता है
मतलब जो कोलाइड करते हैं.
वाइब्रेशन मोशन गाइस occur at very high temperature vibrate molecule vibrate at high temperature so vibration motion in this chapter is possible and other than that you can always expect the translation motion Anvita what is translation motion and one more rotation motion Anvita what is the translation motion straight line if particle move in straight line that is known as translation motion Arpit according to the rotation motion chapter if you calculate total kinetic energy what will be the component in the total kinetic energy
Potential energy.
अगर हमें टोटल काइनेटिक एनर्जी काउंट करनी है इफ वी हैव टू काउंट टोटल काइनेटिक एनर्जी कौन कौन से कंपोनेंट होंगे उस टोटल काइनेटिक एनर्जी के अंदर व्हाट विल बी द कंपोनेंट इन टोटल काइनेटिक एनर्जी
Mass and velocity.
Sir,
देयर विल बी टू मोशन ट्रांसलेशन मोशन एंड रोटेशनल मोशन करेक्ट स्ट्रेट लाइन एंड रोटेशन एग्जांपल इफ
sir,
एनी हाँ प्रतिज्ञा
सर आप लिखवाए थे कि वाइब्रेशन मोशन मतलब टू एंड फ्लो मोशन होता है और रोटेशन मोशन हाई टेम्परेचर में होता है.
नहीं नहीं वाइब्रेशन रोटेशनल मोशन और वाइब्रेशनल मोशन हमेशा ही हाई टेम्परेचर पे होते हैं ना both of this motion vibration rotation usually occur at high temperature because if temperature is normal particle will try to move in the straight path
हाँ.
in SHM I said vibrational motion to and fro at high temperature right
हाँ.
in SHM is again vibrational
हाँ सर.
motion but vibrational motion occur at high temperature यही तो लिखवाया था ना शायद
हाँ. हाँ.
हाँ so here I was talking about the rotation motion chapter example if you have any cylinder and it is moving down. So you can see there are both kind of motion will occur in this cylinder. It will roll, rolling motion, rotational motion, and in rolling motion, it is moving forward. So translation motion as well. And that is what you talk about. There is a separate topic in rotational motion, rolling motion, right, Arpit? Yes or no?
रोलिंग मोशन तो डिलीट हो गया है ना? क्या है?
नहीं, you do have rolling motion.
मैंने स्किप कर दिया स्किप करना.
हाँ, इसीलिए मैं तुमसे पूछ रहा हूँ क्योंकि तुमने रिसेंटली किया होगा, दूसरे लोगों ने अभी किया नहीं है ये टॉपिक रोटेशनल मोशन.
ये मेरा चल रहा है अभी, मतलब 6-7
अब
दिन से चल रहा है.
कंप्लीट. अच्छा, ठीक है. नेक्स्ट. सो Chandana, if you think about the kinetic energy of gases, what are the factor will decide the kinetic energy of gas? In your opinion, what is the major factor? Any guess?
Temperature.
Absolutely temperature. Temperature is the most important factor in the gases. Why? If you increase temperature, kinetic energy of the gas will increase. Particle will move faster. That is the one most important factor in the kinetic energy of gas. Um, Anvita, if you talk about the potential energy, what will be the potential energy in gases?
सर वो तो नहीं है क्लास में.
क्या हुआ पोटेंशियल एनर्जी? Anvita, am I audible?
Yes, sir.
हाँ. Did you miss anything important? Kinetic energy of gases directly depend upon temperature.
Yes.
हाँ. So, Anvita, what is potential energy? In case of gases, what should be the potential energy? What is the potential energy in general?
In like value, sir, or like definition? Value, I think it's 0 for gases.
No, no, not value, definition of potential energy. Pratigya,
फॉर्मूला पता है.
फॉर्मूला नहीं, फॉर्मूला एमजीएच नहीं बताना, या फिर चार्ज इनटू पोटेंशियल नहीं बताना.
और
What is
नहीं पता.
potential energy?
याद नहीं.
Chandana,
It's the virtue of its position.
yes. Arpit, what is potential energy? Is this correct?
फॉर्मूला फॉर्मूला बताइए मुझे.
नहीं 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 नहीं, not formula. Formula I can write minimum 3-4 formula. कि potential energy is equal to mgh. Correct? Potential
यस.
energy is also equal to mass into the this gravitation field intensity. Potential energy is equal to charge into the potential, right? Potential energy
यस.
is equal to half kx square. Correct?
यस.
But what is the definition? These are the formula we use in the different chapter. Potential energy is the energy by virtue of configuration. It is always because of the configuration position. Example, if you keep your pen on the ground, so in this case potential energy is zero. But if you hold your pen in hand for long time, your hand will pain. Why? Because of the height this pen is having potential energy. And when you drop this pen, क्या होगा अर्पित ऐसे केस में?
मतलब
When you drop the
ड्रॉप
pen,
मतलब फ्री फॉल. फ्री फॉल.
free fall हो जाएगा and it will again convert into kinetic energy, right?
kinetic energy. Yes.
So potential energy is converting into the kinetic energy. तो
Yes.
प्रतिज्ञा, मुझे बताओ कि what is responsible for potential energy in this pen?
पता नहीं.
See, this is the ground. This is ground. I had pen here. So in this case, potential energy is 0.
0.
Then you lift this pen with your hand and you keep it here. Okay. So here you have potential energy because of height, mgh. Correct? And if you drop
Yes.
this pen again, then potential energy convert into the kinetic energy. Free fall will happen. Arpit, तुम बताओ, what is the reason for potential energy in this pen?
रीजन मतलब
मतलब कहाँ से आया इसके अंदर ये potential energy? Because here at the floor, this is floor. At the floor, potential energy was 0, kinetic energy was 0, right? Total
हाँ
energy is 0. But when you go up at this position, 1, here it have potential energy. When you drop, kinetic energy. But if it was 0 earlier, अगर ये पहले 0 था, तो आया कहाँ से energy? From where we got the energy?
मतलब हाइट हाइट की वजह से.
नहीं. No. Chandana, what is the cause for this potential energy?
एक्सीलरेशन ड्यू टू ग्रेविटी.
No. Acceleration due to gravity is responsible for kinetic energy.
हाँ
So movement.
And what?
Movement.
Movement, yes. We human being are introducing mechanical energy of our body. Because if you are not lifting this pen, it will never move. It will never get energy. Human body, mechanical force is responsible for lifting pen, right? Yes or no?
Yes.
So I was talking about like JEE advanced question, and you know what is the difference between JEE advanced question and mains and NEET question? I consider mains NEET are almost same. So main difference is in advanced you apply multiple concept together, 5-6 concept from multiple chapter, and here it is like you if you remember formula you can solve NEET and JEE mains question, but you can't solve advanced question, right? So in this case, potential energy is the distance between the molecule. It means if you have a container like this, and here you have two gas particle A and B, distance between them, because of this, you will have potential energy. When they are moving, of course, kinetic energy, but because of distance, potential energy. Correct? Any doubt? So this is because of the position. When we said configuration, position is one part of the configuration because of position. Example, if intermolecular force is more, molecule have more force, then potential energy will be less. Okay. Example, I will talk about this. Intermolecular force, force between the two molecules. Barinder, in your opinion, if we talk about intermolecular force, IMF, कहाँ पे सबसे ज्यादा होना चाहिए? Where we will get the maximum intermolecular force, solid, liquid, or gas?
Liquid.
Liquid.
सॉलिड.
Solid.
सॉलिड सॉलिड में होगा ना.
Solid. Solid. Pratigya? Pratigya, Anvita, Chandana, all of you answer this
Solid.
question.
Solid.
Solid, because in solid particles are very close to each other. They are closer, more force. Then liquid, then gas. Okay. But if you compare, Arpit, if you compare real gas
Yes.
and ideal gas, which will have more intermolecular force? This is a tricky question.
Real guess.
Real gas. Are you sure?
Yes.
100%?
हाँ हाँ.
Should I lock the answer?
4 बार लगे मुझे.
Okay, guys, tell me, कितने लोगों ने ये मीम देखा है उस बच्चे वाला केबीसी में? How many of you have seen KBC little kid video? वरिंदर, नहीं देखा?
देखा है सर।
अन्विता?
हाँ सर, क्या देखा है?
अरे वो बच्चा था ना, वो ओवर कॉन्फिडेंट था.
हाँ हाँ,
There was
देखा
a
है देखा है.
kid, there was a kid in KBC. He was very confident कि सर 4 बार लॉक कर दीजिए, सर कर दीजिए लॉक. And then he lost in second question. Very basic question. Sandana, do you watch KBC like this popular meme?
No sir.
Okay, so answer is yes, real gas. Why? Because in case of ideal gas, there is no intermolecular force. We consider they are not interacting with each other. Okay, so in case of ideal gas, intermolecular force is zero. But in reality, they do apply small amount of force. So this is about intermolecular force. Pratigya, tell me what should be the potential energy in this case? Solid, liquid, gas, real gas, and ideal gas. Answer is ideal gas will have maximum potential energy. Why? Because they are at maximum distance. Makes sense? More distance, more potential energy. Any doubt, guys? अर्पित, you tell me. अर्पित, तुम्हारा ये चैप्टर हो गया? Electrostatic. Are you done with electrostatic?
सर वो भी क्लास
अर्पित,
में ही है.
वो क्लास में नहीं है? वो आ जाएगा. हाँ. Anvita, you are done with this chapter of gravitation.
No sir, they will start.
They will start. Arpit, you are done with gravitation or electrostatic?
नहीं नहीं नहीं.
Okay. Okay.
और याद है याद
So,
है याद है.
याद है. If
थोड़ा
two,
थोड़ा.
if unlike particle are kept closer, what will be
Yes.
the impact in the potential energy?
Unlike particle.
Two charged particle. Example, if you have A charge, B charge. A is positive, B is negative. If they kept close, what will be the amount of potential energy? It will be less or more?
Less.
Less.
हाँ.
And if you keep two like charge closer to each other, what will be the potential energy?
More.
More. Yes. Why? Potential
मतलब
energy try to resist any change. Example, in case of like charge, they are repelling each other. You have to hold them and bring closer. You have to put maximum force. This maximum force is potential energy. Everybody understood that part from electrostatic? If you have two like charge, either positive or negative, they will repel each other. तुम उनको पास में लेकर आओगे, पास में लाने के लिए तुम्हें बहुत सारा फोर्स लगाना पड़ेगा, बहुत सारी एनर्जी लगानी पड़ेगी, तो पोटेंशियल एनर्जी पॉजिटिव होगी. When you bring them closer, you have to put a lot of force, lot of energy. It means potential energy will increase, energy overall will increase. Make sense?
Yes, sir.
So that's why in case of ideal gas, because they are at maximum distance, that's why their potential energy will be maximum. We talk about one more energy, internal energy. Anvita, if you heat a body, what will be the impact on the other factor according to thermodynamics? अगर तुम एक कंटेनर को गर्म करती हो तो तुम हीट सप्लाई कर रही हो. इफ यू आर हीटिंग अ कंटेनर, यू आर सप्लाइंग हीट. What will be the impact on internal energy and work done?
Because of heat,
Yeah,
right?
because you are supplying heat.
Internal energy will increase.
Internal energy will increase because
And what's the other
example,
thing you asked?
same thing. Your answer is correct. Example, you have a closed container. Here, gas particle are present. If you heat this, if you supply heat to this, what will happen? It will increase internal energy or it will do some work, right? That is why first law of thermodynamics is delta Q is equal to delta U plus work done, right? If you supply heat, it will convert into internal energy or it will do some work. Maybe container will expand. अच्छा, तुम लोगों ने देखा है ये बात, लाइक हैव यू सीन दिस थिंग, कि कई बार जब तुम वो पाइप, गैस की पाइप इंसर्ट नहीं होती स्टोव में, तो तुम उसको थोड़ा सा गर्म पानी में डाल देते हो और वो थोड़ा सा फूल जाती है और फिर वो आ जाती है आराम से. लाइक यू हैव
Yes,
सीन
yes.
when you take a pipe, gas pipe, and you take stove and you are not able to insert the pipe, then you heat it in hot water and then you can put it easily.
Yes.
Mm.
Definitely.
है ना?
Yes.
Why? Because when you heat the wire or this pipe, it it will do some work done, and because of the work done, it will expand. Work done positive means it will expand, and particle will be loose means increase in internal energy. So you are not supposed to remember first law of thermodynamics. It's just whatever heat you supply to the system, either it will increase the internal energy or it will do some work. Got it? That's why.
Yes.
So internal energy is actually the sum of kinetic energy and potential energy at a given temperature inside the container. So this internal energy is the sum of potential energy plus sum of kinetic energy. If you add both of them, that will be the internal energy of the container contain gas.
अरे इंटरनल एनर्जी एंड टोटल एनर्जी सेम होता है.
हाँ, for gases. इंटरनल एनर्जी का मतलब क्या है कि एक कंटेनर है, क्लोज है. यू हैव ए कंटेनर दैट इज क्लोज एंड इफ यू हीट इट, वर्क डन तो हो नहीं सकता. वर्क डन इज नॉट पॉसिबल.
नहीं.
व्हाट विल हैपन? पार्टिकल विल मूव विद द फास्टर स्पीड. क्या हो रहा है? पोटेंशियल एंड काइनेटिक एनर्जी चेंज हो रही है, राइट? पोटेंशियल एंड काइनेटिक एनर्जी चेंजिंग बिकॉज ऑफ द हीट, राइट? मेक सेंस?
Yes.
Example, if you take solids, in case of solids, total kinetic energy will be same. Whether you take solid, liquid, gas, total kinetic energy, it will be same. So I'm writing this key total kinetic energy will be same. And when I'm telling total kinetic energy, I'm talking about internal kinetic energy. If we are moving the container, that is external kinetic energy. We are not including that part. Okay. So it is same for all. Same for all means for all gas, liquid, or solid, internal kinetic energy is same. But what will be the impact on the total potential energy, Arpit? Internal potential energy.
गैस में जीरो होगा.
गैस में जीरो होगा, आइडियल गैस में.
हाँ हाँ हाँ.
हाँ. In case of ideal gas, yes, it will potential energy will be maximum and it will be zero. Zero, but maximum. तो मिनिमम किस में होगा?
Solid.
Solid. In case of solid, it will be minimum. Why? Because it will be negative. Right? Because it will be negative. In case of Earth, Chandana, what is the maximum potential energy?
Sir, can you repeat the question?
Yes, Chandana.
Sir, can you repeat the question?
My question is, in case of Earth, if you consider potential energy in the gravitational force, what is the maximum kinetic energy?
Kinetic energy, sir.
No, potential energy. My bad. Potential energy. The Earth, in case of Earth, what is the maximum potential energy?
Maximum potential energy MCH होगा. क्या मतलब zero. Zero.
Yes, maximum potential energy will be zero. सबसे ज्यादा पोटेंशियल एनर्जी अर्थ के केस में जीरो ही होती है. क्यों? मोस्ट ऑफ केस में ये नेगेटिव होती है. इन मैक्सिमम ऑफ केस whenever there is a attraction, it will be negative potential energy. Right? Whenever there is attraction, negative potential energy. Same thing is happening in solid, liquid, and real gas. There is some kind of attraction. That's why potential energy is negative. And even in this chapter, which chapter? You have this binding energy, right? In atomic structure or atomic this atom and nuclei physics, correct? In atom and nuclei of physics and in chemistry, atomic structure, you have this concept that is binding energy. And you will see binding energy is always negative, right? Binding is always negative. What is the maximum binding energy? Zero. It means when there is no interaction between the two molecules, so there is no binding between that molecule, so it is maximum, it will be zero. Understood, guys?
Yes.
Yes, sir.
Yeah. So this is really important. That this is what we are doing. We are not just doing kinetic theory of gas. We are understanding different chapter ki how wherever you have gas, you have to always correlate with the kinetic theory of gas. Okay. Now we will enter into the mode concept chapter, number of moles. Right? How to calculate number of moles, because this is crucial in this chapter. Like very basic, but still I'll ask. Uh, Pratigya, what is number of moles?
Weight by gram molecular weight. Given
Given
by
mass by molar mass.
mm,
Anvita, what is the other form of moles?
What's the other formula?
Moles.
As in, like, I don't understand.
Like you can calculate moles in the form of mass in case of volume or in the term of molecule. Arpit, what will be the mole in case of a molecule?
Number of particles divided by Avogadro number.
Yes. Number of particles divided by Avogadro number 6 into 10 raised to power 23. That is the moles, and it is represented by nu moles. It is your choice. You can represent by anything. It doesn't matter. What really important is from the mole concept chapter. This is how we represent moles. Correct. And what is the R value, Varinder?
8.3
8.3 unit. Unit.
joule per Kelvin per mole.
Joule per Kelvin per mole. Are you sure?
Yes, sir.
Arpit, is this correct?
Joule per yes, yes. मैं याद नहीं यूनिट याद नहीं होता वैल्यू याद
Unit याद नहीं. Okay. Chandana, is this correct?
Sir, joule per kg per mole.
Joule per kg per Kelvin. Anvita,
Well, I'm not sure.
Pratigya.
याद नहीं है सर.
Wow, wow, guys. Let me tell you how to calculate unit. PV is equal to nRT. PV is also equal to work done. Work done unit is joule. You want to calculate R unit. So can we say it will be work done divided by NT? So work done is joule. N is number of moles and T is Kelvin. Tell me, was it really difficult?
बिल्कुल
So,
नहीं.
Vrinder, what you said was correct. Joule per mole per Kelvin. But everybody should know how to calculate unit. Work done, joule, number of moles, temperature Kelvin. Yes, it is the correct answer. Anvita, in case of calorie, what will be the value of R approximately?
1 point something, right?
987
1.987. Approximately 2. Yes, I will write below because R value in the form of calorie is 2 calorie per mole per Kelvin. Remember, no, they will not ask you the values, but unit is always important. Chandana, tell me, 1 calorie is equal to how many joules?
So 4.2.
Yes, approximately 4.2, or sometimes we write 4.18, approximately 4.2 joule. Yes, that's why if you take 8.4, it will be exactly 2 calorie R value. Correct? Uh, Pratigya, you tell me what is the specific gas constant value? Pratigya, make it fast.
मतलब सर फॉर्मूला बताना है, फॉर्मूला बताना है।
हाँ हाँ,
R/M.
R by M. Yes, this is really important. Formula is R by M. So, Arpit, what should be the unit?
जूल केजी इनवर्स केल्विन इनवर्स।
Joule per kg?
जूल केजी इनवर्स केल्विन इनवर्स।
Yes, Joule per kg per Kelvin. Correct. This will be the unit of specific gas constant. Uh, Chandana, what is Boltzmann constant? Because we're going to use all these things in this chapter. And if you understand today's class, I can finish this whole chapter in 3 class. Boltzmann constant, KB.
Sir, I don't remember.
Arpit,
केटी मतलब कैटेलिक काइनेटिक एनर्जी इनटू टेम्परेचर, एक्चुअल टेम्परेचर।
R by number of Avogadro number,
सॉरी
right? So what is the R value? It is 8.31. Avogadro value 6 into 10 raised to power 23. So what should be the answer? 1.38 into 10 raised to power minus 23. Correct? So don't remember KB value. Always just understand K Boltzmann constant is the gas constant divided by Avogadro number. Right? What should be the unit, Brinder? Brinder unit.
So don't know.
Joule per Kelvin. Joule per Kelvin. Got it? Joule per Kelvin. Why? Because Na is kind of like number of moles, so a mole will be cancelled out. Got it? Then we will use some other simple thing that is not really important, but symbol I'm going to use so it will be helpful for you. If you consider the mass of one gas molecule, you know one gas molecule mass will be very, 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 very small. So we'll keep it small m. If we take total mass of complete gas molecule, we're going to use capital M. If we consider molecular weight, then you can use MW. And even this is also MW. Specific gas constant is gas constant divided by molecular weight. Okay. So number of gas molecule, if we consider, then you can take, and why I'm writing all these things? Because some teacher use different symbol for all these things. Okay. Some people use mass of the gas as W. Other people use only M. So it will be easy for you to remember this. Based on this, Anvita, tell me what should be the molecular density. Molecular density. I'm using small n for this.
Sir, I don't remember numerator, but in denominator, I think it's volume.
Denominator it is volume. Numerator. It is not normal density, so it can't be mass by volume, right?
Yeah.
नंबर ऑफ मॉलिक्यूल।
Yes. Because we are talking about the molecules, that's why it includes number of molecular density. We try to understand this. Don't memorize this topic because we're gonna use throughout this chapter. Just remember, like not remember, just go through it once again because all these are the symbol we will use in full chapter. Last, gas density. Arpit, what is the gas density?
Yes. Mass by volume.
Exactly, mass by volume. Here we take total mass of gas, mass by volume. And if you take in the molecular density, how you gonna write? Can you write mass of a molecule multiply by number of molecule, volume remains same. So
Yes.
can we also say कि mass of gas is equal to what is the number of molecule and mass of one gas? Though it will look tough, let me give you the easiest way. If one person weight is 100 kg, what will be the weight of 15 people each having 100 kg weight?
100.
1500. Same thing. What is the mass of gas? Total mass of the gas. Mass of one particle multiply by number of particle. Example: one particle mass is 1 gram. 1,000 particle mass will be 1,000 gram. Done. Mass of gas. So can we say that this density is also equal to mass of one gas particle multiplied by molecular density? Correct?
Yes.
Huh. So this is the introduction part of this chapter, because after that we are going to start what are the assumption, postulate of kinetic theory of gas, then ideal gas. Ideal gas part you already understand, right? Charles law, Boyle's law, Gay-Lussac law. It will be easy for you. It will be quick revision. I will finish all this law in just 5 minutes. I'll tell you, okay, we did this in thermodynamic. We did this in thermodynamic of physics and chemistry both. But I'll try to give slightly more time to average velocity, mean speed, most probable speed, RMS speed. These kind of question you get in the NEET exam as well. Pressure, pressure is the most important topic from this chapter. So in 3 class, I'll finish the full chapter. Got it? Enough for today.
हाँ सर
हाँ, प्रतिज्ञा सबसे ज्यादा खुश हो रही है सर, आज तो सोने का मौका मिलेगा।
हाँ
Okay, enjoy. Tomorrow we will have class, one in afternoon,
Subha.
one in evening. No, not in morning.
Okay.
Okay.
सर मेरा
And
एलन है
पता नहीं, हाँ फिर we have class in afternoon, like
आफ्टरनून
4-5
मतलब
o'clock,
कब
4-5
4 o'clock
around.
कर सकते हो
हाँ, so we'll make it 4:30 afternoon, one class, and one class in night exactly at 9 o'clock. Okay, so there will be 2 class. Let me give you assignment. As I mentioned, in every class you will have assignment. Your thermodynamic is not done yet. Remember this. You have to continuously ask me question from thermodynamic. So today's assignment before sleeping is sending me notes, sending notes of KTG, kinetic theory of gas, whatever we did so far. Okay, not many questions you can solve from this. Tomorrow morning, this is before sleeping. Before sleeping means before 12 o'clock. Okay. In morning task you have one. You have to solve 20 questions from thermodynamics. You can ask doubt. And 10 questions from thermal property of matter, because we have to revise previous chapter as well. 10 questions from. Oh, by the way, tomorrow you have test, na?
हाँ
Thermal property of matter. Tomorrow you have test from 2 to 5. Okay, and you will have full biology syllabus as such. Okay, I'm not expecting much, but I want to see your 5 chapter, whatever we finished thoroughly. Okay,
ओके सर
5 chapter. I'm looking for key. Will in detail discuss 5 chapter. Other thing you can manage. So tomorrow, if you have test, you should have more question. I will increase question because of the test.
So
Here
can
you
we
have
test day after tomorrow?
nahi tomorrow 2 or 2 na
Yeah,
30
I'm
30
saying
question.
can we have on second, third, no, also?
No. Tomorrow you will be have a test at 2 o'clock sharp. 2 o'clock I'll send.
मैं
If
कैसे
Anvita example you are coming late, you can write late.
Okay.
Okay, but you will not have afternoon class. You will have evening class, and we will discuss physics of tomorrow's test. Okay,
पीडीएफ
PDF of what?
सेंड कर दीजिए
हाँ, PDF I'll share. मुझे याद दिला देना. And
सर
test
अभी है
PDF
वीडियो
I'll
वाला
send sharp at 2 o'clock. Keep your OMR sheet with you. Send me OMR sheet plus rough work. Okay.
तो मेरे 2 से
OMR
5 टेस्ट।
कोई बात नहीं, वो टेस्ट लिख लेना, बाद में लिख देना इसको.
हाँ
तो इसको बाद में लिख सकते हो, बट ये अटेम्प्ट तुम्हें भी जरूर करना है.